All right, Calc BC, Unit 3, Day 8, office hours. This is assignment, page 535, 2028 even. On first problem, first couple problems says sketch the curve over the given t interval in a direction, which say identify the requested point and justify that you have found the requested point by analyzing. So this is a couple more EVT kinds of problems. So 20 is x equals tangent t, y equals 2 secant t. Time interval is from -1 to 1, and we're looking for the lowest point, which is the min y value, min y coordinate. We need to use the trig identities. Pythagorean trig identities. Sine squared plus cosine squared equals 1. Divide everything by sine, you get 1 plus cotangent squared equals cosecant squared. Divide everything by cosine, you get tangent squared plus 1 equals secant squared. And that's one we need to use for this problem right here. So I memorized the first one and I create the other ones pretty quickly. So I'm going to try and write that equation. Tangent is just x, so it's just going to be x squared. And secant is y over 2 squared. We want the 1 to be positive, so we can flip both sides. Y squared over 4 minus x squared over 1 equals 1. That's your Cartesian equation. That is a hyperbola. Make a table, which will actually help us for our EVT problem, because that's what we usually do. Put -1 in, +1. We could start sketching this graph. It's a hyperbola. Draw a box. Draw a diagonal. This one's going to be up, down. The y squared term is positive. Okay, so now if we plug -1 in, it's going to be sine over cosine. Now I feel like these are going to be some weird values, so we're going to probably use our calculator to help us. I don't know, just for the sketch, because angle 1, -1 is not easy. So this is going to be a tangent of -1. Now on your calculator, that's going to be, should be in radio mode. Radio mode. So tangent of -1 is that value. So -1.557. And then 2 secant. Secant is 1 over cosine. So it's going to be 2 over cosine -1. Again, not a value I know. So 2 divided by cosine -1. My calculator gives me 3.701. Tangent of +1. And 2 over cosine of +1. Is positive 1.557 and positive 3.701. So on our graph, -1.57 x would be around here up to, so it's somewhere like around here is our initial point. And we would just write it exactly. Tan -1, comma 2 secant -1 is your initial point. And then the other one's going to be over here on the other side. It's going to be like around here. So that's going to be tangent positive 1, comma 2 secant positive 1. That's our terminal point. So I think we're going like this. And we could calculate something in the middle. Probably will. And we'll confirm that later. Because I think we'll end up finding this point because that's a relative min, which we're probably going to try. So we want to find, we're looking for min y, which is going to happen when the tangent line has a slope of 0, but more specifically when y is not, when the derivative of y is 0, because that means y isn't changing at all, or I guess undefined. So dy dt is derivative secant is secant tan, so 2 secant tan, and we're going to set that equals 0. Now secant is 1 over cosine, and tangent is sine over cosine. So this is the same as 2 sine t over cosine squared equals 0, which means that's got to equal 0, right? So I guess we could look for when cosine equals 0, which is probably in the hyperbolus, and we could go ahead and do that. That'd be undefined. Just see what happens. Okay, so sine equal to 0 happens when t equals 0 plus pi k. So for us, 0 I think is the only one we want, like pi, negative pi, those are all outside of the boundary. So that's your critical point here. We could look at cosine squared equals 0, which is cosine equals 0, which is going to happen at pi over 2 plus pi k. Now pi over 2 is like 1.5, so we get no values here to even consider. Okay, so all right, so let's put 0 in here, which was probably a point I would have picked anyways, just for fun. Sine of 0 is 0. And then 2 over cosine of 0 is 1, so that's 2, 0, 2, which looks perfect. That's right on the graph, right in between. And this is the minimum value right here. This is the max value, highest points, tie. So we got our answer. So we're going to say the lowest point is 0, 2 at time t equals 0 by extreme value theorem, checking in points and grid points. There we go. Okay, 22. X equals natural log of 5t. Y equals natural log of 4t squared. T is from 0 to 10, and we're looking for the rightmost point, which is going to be max x. All right, maximum x. So can we get this into a Cartesian equation? It's going to be kind of a little gross, I guess. So I would solve for t here. So I get e to the x equals 5t. So t equals e to the x over 5. And then I plug that into the other equation. Y equals natural log of 4 e to the 2x over 25. I believe we could try and clean that up using log rules and say, well, this is 4/25 plus natural log of e to the 2x. And we could even say, And then those would cancel. So we say 2x plus natural log of 4 over 25. That's our Cartesian equation. Now, that might seem weird, but that's a line. This is going to be a line segment. Or actually, yeah, I don't know, we'll see. It's going to be a line. That's just a number. This is totally slope-intercept form. So let's make a table and plug the endpoints in at least. I'll just do 0 and 10 to start with. Leave some space in between. Natural log of 0. Well, as we go to 0, it goes to negative infinity. Both of these go to negative infinity. That's weird. So not really an endpoint on that side. It's going to go on forever. You plug 10 in, it's going to be natural log of 50 and natural log of 400. I mean, we could try and estimate this, or we could use our calculators. But asking yourself, what do you raise like 2.72 to get 50? Well, 3 times 3 is 9, times 3 is 27, times 3 is 8. I mean, it might be around 4, would be my guess. Close to 4. That'd be my guess. On your calculator, it is 3.912. So 4 is not bad. 400, well, that's 4 times another 2.7 would be like 125. Times another 2.7 would be 3. I mean, this might be around 6 or so. On your calculator, it is 5.991. So, we can do some rough estimate. So let's graph what we have. It's a line. Now, natural log of 4/25 is, it's for sure negative because the natural log graph, here's 1, and 4/25 would be like right here. It's probably kind of a big, I don't know, big negative number. I don't know. So on your calculator, let's see what it is. Natural log of 4/25. So I feel like it's hard to estimate these ones. No, it's not that big. Negative 1.832. Okay, so it's a line. And negative, it's right around there, and then goes up to over 1. So up to over 1. Up to over 1. Something like this. Now, we already know this point right here. I guess I should have made my graph bigger. It's almost up to 4 and up to 6. 1, 2, 3, 4, 5, 6. So it's kind of like it's somewhere around here. That's the initial point. And then it goes down to negative infinity. So we put an arrow on this end. This end is just a dot. This is a ray. So this is the initial point. Actually, no, that's the terminal point. That's weird. That's the terminal point at natural log 50, comma, natural log 400. Okay, and then it actually goes this way because that's the terminal point. So it comes in from down here. Now this arrow right here it's not trying to indicate direction. It's just that the graph keeps going on forever. So this ends up being a ray. A ray is a line that has an endpoint on one and not the other. Now we're looking for the max x, which looks on our picture to be that, but we need to show some work to verify it. So if you're looking for max x, that generally corresponds to when dy dx is undefined because it's vertical motion, which is when dx dt equals 0. So we can look for that. Dx dt is 1 over 5t times 5. So it's 1 over t, and we're going to set it equal to 0. Or I guess we could look for undefined. But so, I mean, that's only possibly times 0. Well, clearly that is an extreme location, right? That's that would be the leftmost point, which is impossible to quantify because it goes to infinity. So this, that kind of makes sense. But that's it. We don't really have any critical points outside the endpoints, and we can't really go to zero. So this is going super, super negative. This is the only, and then it's getting closer and closer to this. This is your rightmost point right here because it has the biggest x value. That's your leftmost point, which we can't really say is a point. It just goes left forever. So the rightmost point is natural log of 50, comma natural log of 400 at time t equals 10 by extreme value theorem. Checking endpoints and critical points. Yeah, so this was just a little more practice on what we've been doing previous days. We already had some of this on homework last assignment. Okay, next problem. 24. These ones are different. They say find the points at which the tangent line to the curve is horizontal and vertical, which is kind of what we were just doing just now to find the critical points. But now we're not looking for absolute max mins. Okay, so 24 x equals secant t, which is 1 over cosine t. Y equals tangent t, which is sine over cosine t. And we don't have any time domain because we're not doing that. So I want you to go ahead and sketch the graph. Let's just get a little more practice with that. So we want the one with secant and tan, which was the one that we used on problem 20. So this one's tangent by squared plus 1 equals secant is x. So x squared minus y squared equals 1. That's your Cartesian equation. It's a hyperbola. So pretty easy. We could sketch it. So let's see. I'll sketch it here. So box, diagonals. Okay, this one's gonna be a right-left graph, and if we put any time in, then it's gonna be the whole thing. So I'm just gonna draw the whole thing. We don't really have any time limits, but this would be the curve for any time, and so we're specifically interested. Okay, well, yeah, let's draw the whole graph. So part A says we're going to try and find horizontal tangents. Well, where do horizontal tangents happen? Well, they happen just like last year for any kind of graph when the slope is equal to 0, which is going to be when dy dt equals 0. Hopefully dx dt doesn't equal 0 at the same time. If it does, it's not necessarily bad. It's just going to be more complicated to find it. So let's find dy dt. Now, by the way, on the picture, do you see the horizontal tangents? No, I expect to get none from this. So the sketch is telling me that, but I want to show the work. So derivative of y is going to be secant squared, which is 1 over cosine squared. And we want to know, when does this equal 0? Never. I mean, this can never, you never can divide by 1 by anything and never get 0. So there are none, right? Part B, vertical tangents. vertical tangents happen when the slope is completely vertical, which is going to be undefined because you're dividing by 0. It's all, it's all vertical. So that's going to be when dx dt equals 0, and all the motion is in the vertical direction. So we find dx dt, which is going to be secant tan, or 1 over cosine, sine over cosine, equals 0. So that's going to be when sine equals 0. And so that's going to be time equals 0 plus pi k. And so this is, I guess this is kind of interesting. If we were to graph this, times 0 would be 1. So this one would, so if we were to just start, I mean, there's going to be a bunch of values, right? It's going to keep going. I mean, even negative ones. But what's going to happen is as we keep going, the graph just repeats itself. So we could go on for infinity listing all the different times. So it really just happens at a couple coordinates. So times 0, we get the coordinates of 1, 0, which is on the graph. And look, sure enough, that's where you expected an answer, vertical tangent, and then another one right here. So we expect to get these two answers at pi. Cosine of pi, that's -1, 0. Perfect. So then that's all we need. Otherwise, we keep getting the same ones over and over again. It repeats same answers at these other times, but they're the same points on the graph. So we're not going to list the same points over and over again. So it's kind of interesting from the graph. We can see when that's going to happen. Okay. 26, same kind of problem. X equals -2 plus 3 cosine t. Y equals 1 plus 3 sine t. There is no time interval, so I'm going to try and get the Cartesian equation for this real quick just to get a sketch. I want you to do the same thing. So it's going to be sine squared, which is going to be y minus 1 over 3 squared, plus cosine squared, which is going to be x plus 2 over 3 squared equals 1. I think that looks like a circle that's been shifted. So what we usually do is we do this. Usually put the x's first and the y's, and then we get 9s that we'd multiply over here. So this is a circle. And so we could go and sketch it with a radius of 3. But it's been shifted to the left 2 and down, up 1. So I probably should have made my graph more this way. So left 2 and up 1. So that's the center of the circle, and it has a radius of 3. Now I'm just going to darken the whole thing because we're not restricted to any certain times. It's just going to keep repeating itself. But that's it. Now, part A, we're looking for horizontal where the slope of the tangent curve is horizontal. And we can see that in the picture. It's here and here. So we already know what the answers are. This is -2, 4, and this is -2, -2. But we're going to show the calculus to find it. So that's going to be when dy dx So if the tangent line is 0, which is going to happen when dy dt equals 0. So dy dt is 3 cosine t equals 0. So that's going to be pi over 2 plus pi k. Now, so we can get pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2. But these answers are just going to start repeating themselves. So when you plug pi over 2 in, cosine of pi over 2 is 0, so you get negative 2 for the x, and sine of pi over 2 is 1, so you get 4, sure enough. And at 3 pi over 2, that's a third quadrant, cosine is 0, so we get negative 2 for the x, and sine is negative 1, so we get negative 2 for the y. And then they just start repeating themselves, right? Okay, part B is vertical tangents. And so that's going to, we see them on the picture. We expect to get one at 1, 1, and at negative 5, 1. Right? So let's see if the answer gives us meaning when dy dx is undefined, completely straight up and down slope, infinite slope. Just going to give you when dx dt equals 0. And so then dx dt equals negative 3 sine t equals 0. So it's going to be a 0 plus pi k. So 0, pi, 2 pi, negative 2 pi, infinite answers. But we only expect to get 2 of them, and then they're just going to repeat themselves. So when you plug 0 in, which is probably easier, cosine 0 is 1, so you get 1 comma. Sine of 0 is 0, 1 comma 1. Perfect. Okay, let's try pi. Cosine of pi is negative, so it's going to be negative 5, and that's going to be 0, negative 5, 1. Those are 2 answers. They happen there. Perfect. Okay. All right. 28 says, find the length of the curve for an algebraic challenge. Try evaluating the integrals without a calculator. So I'm giving you that challenge. I want you to try and do it without a calculator. So these ones are just trying to find the length of the curve. So here's x, here's y. Now we don't really need a graph to calculate this, but I want you to go and graph it, and then it'll actually kind of help make sense of your answer, because you might be able to use a different technique to find the length. So sine is x over 3 squared, cosine is y over 3, and then squared equals 1. So it's going to be x squared plus y squared equals 9. So this is a circle, which is going to be convenient for maybe calculating arc length, because we kind of have some circles that we can do arc lengths of around the whole circle's circumference. So I don't know, we could sketch this graph. It's centered at 0, 0 this time. And we do have endpoints, initial and terminal points this time. So I'm going to do a little table right after this. So I'm going to do this one lightly, unlike the last couple. All right, so if we make a little table, plug 0 and pi in. So sine 0, 0, this can be 0, comma 3. No, not that one, this one. 0, comma 3 is the initial point. Plug pi in, we get 0, comma negative 3. That's the terminal point. And then so I think we're only getting half the circle, but which half and which direction? Let's plug pi over 2 in. That's going to be 3, comma 0. So it's the right half of the circle. And the direction is going from initial to terminal point, and we're trying to find the length of that. Well, that's half a circle, so we could calculate that really easily without calculus, but we're going to use the calculus. So the new formula we learned was that the length is equal to the integral speed, just like last year, 0 to pi. But speed is now calculated by the square root of dx dt squared plus dy dt squared, integrated with respect to t. So dx dt is 3 cosine, and dy dt is negative 3 sine, but squared, dt, need the dt. Now, we're going to try and do this. I mean, we do this on a calculator, but let's see if we can get the answer without it. So this is going to be 9 cosine squared plus 9 sine squared. How could we simplify this? Like, we could factor the 9 out, right? And cosine squared plus sine squared, that looks familiar, right, is 1. So it's going to be the integral of 3. The antiderivative is 3t. We're going to plug in the limits, and we're going to get 3 pi for the answer. Okay, how about if we use our old geometry formula, that this clearly is half the circumference of a circle, so half of 2 pi r. And the radius is 3. Hey, that works. I mean, that's usually not going to be something you can do, but there you go. All right.